Hi, my name is Lauren McBurnett. I'm a PhD student here at Arizona State University, and I'm researching games for fostering complex systems reasoning skills. Today I'm going to tell you how simulation games can be used to acquire and practice complex systems thinking skills. I'd like to take a moment to thank my collaborators Susan Clark, Margaret Hinrichs, and Tom Seeger. You might be wondering, why do we need to understand complex systems? Well, failures occur in all systems, and in order to prevent those in complex systems such as infrastructure systems, we need to understand the logic of complex systems. One such oversight of a complex infrastructure system was observed through the drought conditions in California. Due to the drought, they had reduced in-stream flows, which corresponded to reduced hydropower generation. As a result, the demand for power needed to be met through other power plants, which their efficiency had been reduced because of temperature as well as the transmission line's capacity. So in the end, you saw additional water increases being used to generate power from the power plants, all because of the drought conditions of having less water. So it's important that people understand to think about infrastructure the right way. We must understand how complex systems work. My research, which uses simulation games to teach complex systems thinking skills, focuses on 4 different traits of complex systems thinking. The first being interdependencies, describing the relationship between systems. Secondly, I want to teach feedback loops, such as the hydropower California example given in the slide above. Thirdly, nonlinearity. A trait of all complex systems is that they are nonlinear, which means that one input to the system might correspond on a single case to an output, but that same amount of input might correspond to a much larger or smaller output. Stochasticity is the last trait, which is the degree of randomness that emerges in complex systems. Before we can change the way people think about infrastructure or have them think about infrastructure using complex systems thinking skills, we must first understand how people think. From Daniel Kahneman's Thinking Fast and Slow, we learned that people use 2 mechanisms for thinking. System 1, which is their fast and unconscious, automatic intuitions about everyday decisions, versus their System 2. This is what you traditionally think of as thinking, where it's a slow, conscious, and effortful process that's used to make complex decisions and is more reliable. Though people think using both systems 1 and 2, my work specifically targets using systems 2 while students learn the complex systems thinking skills, which are effortful and conscious. And then, using the gaming platform, students are given the opportunity to practice. And through that deliberate practice in games, their systems thinking skills go from being a systems 2 process with lots of effort to being a systems 1 automatic property. From the Kolb learning cycle, we see that students learn in 4 different quadrants. 1 is conceptualization, and that's where you're learning abstract skills. Secondly, students learn experimenting. Third, you have experiencing, and 4th is reflecting. Experiencing is something that's not seen in traditional education settings because experience relies on the use of a real-world context. When it comes to infrastructure, we can't have civil engineers out in the world experimenting before they've learned how buildings need to be built. So with the use of simulation games, we can get as close to performing in the real world as possible without real-world consequences. In partnership with the Decision Theater here at Arizona State University, we've developed a series of simulation games for teaching students complex infrastructure systems thinking skills. We've put the students in the drum at the Decision Theater and asked students to take on and play out the role of a decision maker in the series of infrastructure systems. Allow me to introduce you to our first game, the LA Water game. The story behind the LA Water game starts a few years back when all of a sudden Los Angeles Times and several other LA papers started reporting on huge, massive, day-long, exploding water mains that were flooding the streets of Los Angeles Water County. Engineers and city managers were put on record saying that it's all right, it's only going to take the next 300 years to replace all the water mains. You should be asking yourself, 300 years? That sounds crazy. But could you do a better job managing LA water? That is where our game comes in. The LA Water game asks students to manage the LA water distribution system without getting themselves fired. They're responsible for 3 parts of the city: the system's quality, the public opinion, and the funding. Students are divided into 3 teams representing 3 separate generations. Every 5 years, the generation at play is asked to make 2 decisions. First, how much, in terms of millions of dollars, do they want to spend on maintaining the quality of their system? Secondly, they decide how much they want to charge their ratepayers. Students can be fired 3 different ways. Firstly, if their quality drops below 25%. Secondly, because they're a publicly elected official, they must keep the public rating at above 25%. And thirdly, they can't run their city too far into debt, so at debt exceeding $200 million will also get them fired. The game takes about an hour and a half to play, with an optional half-hour addition for replay. In the LA Water game, the first generation is asked to step on deck. They start out with the system in pristine conditions, where their system quality is at 100% and their public opinion is 100%, and they have money in the bank from last year's fees. Every 5 years, when they make their decision of how much to spend in terms of millions of dollars to maintain the quality, or how much they're going to charge the ratepayers, will affect the status of their system. At the point where it's been 25 years, Generation 1 is allowed to retire and pass along the system to Generation 2. But usually by this time, the system is not in pristine conditions. There's less money, the public doesn't like them as much, and it's the Generation 2's responsibility to pick up the bill. Generation 3 is given the conditions after Generation 2 has retired or been fired. The LA Water game is highly engaging, and as students play out in the decision theater, we see lots of interaction between generations and even a degree of frustration for those who are given the system in worse conditions. Students learn feedback loops, nonlinearity, and stochasticity. We've played with engineering students, veteran students, computer science students, decision theater staff, and American Indian Policy Institute staff, all at Arizona State. We've also played the game at the Naval Postgraduate School with some of Dave Alderson's students. If you're interested and would like to play the LA Water game, please contact me at my email shown below to join one of our Spring 2017 LA Water game sessions.